Hi, today I want to explain about definition of cofactor expansion. First, a method for calculate the domain of a square matrix. Second, it involves expanding for determine a row or column. Third, multiply the minor by its cofactor by need to look the position of minor because it have a position in matrix positive or negative. It is a row I for row, J for column. Other than that, we need to determine all the sum of this equation. Finally, we use this cofactor expression when small matrix like 3 multiply 3 or less. Next, I want to explain about application of cofactor expression. They have two examples. First, bright load calculation, civil engineering. And the point is determine the shear force on bright supports and used to compute determinant of 3 multiply 3 matrix when solving the system manually, especially in static problem where the system of equation represent force balance. Second, 3D module equation in graphics engines. Application area that they use in computer graphic and game development. And the last point is the example is inverting transformation in matrix to revert an object position or rotation in a 3D game or rotation.
Purpose for this study. Firstly, to understand the mathematical connection between geometry and linear algebra. This study aims to show how concepts from linear algebra like cofactor expansion and determinants can be applied to solve geometric problems such as calculating the area of triangle. It demonstrates that matrix operations are not just abstract concepts, but they have real-world applications in geometry and spatial analysis. Secondly, to learn an alternative method to calculate area. Instead of using the standard geometry formula, this method introduced a matrix-based approach, which is especially useful when dealing with coordinate points in 2D space. This method is efficient and systematic, particularly when solving problems involving multiple triangles or in programming environments. Thirdly, to strengthen understanding of cofactor expansion by applying cofactor expansion to a real problem, which is area of triangle. Students gain a deeper and more practical understanding of how the method works. It also helps reinforce skills in matrix manipulation, minor and cofactor calculation.
So for today, I will use this example of problem statement to show you how to solve it. So first of all, in this problem statement, you need to know which is the equation that you will use later. So as you can see, this problem statement already states that they have three of equations which contain x, y and z. From this equation, you need to convert it into matrix. So each row and each column will contain the value of x, y and z. First of all, you need to list down the value of x, y and z before you turn it into matrix. Later, I will show you how to do it. Let's start with M11. So for M11, we need to deselect the first row and the first column. So the rest of the numbers is we use to calculate the minor. As you can see, after we deselect the numbers, we can saw the 3, 1 and 1, 4. That is the matrix we put to calculate the minus. So the formula is you need to do cross, but I create my new formula that I will remember by my own and understand by my own, which is I use butterfly method. So from that, I will show you how to use butterfly method. So as you can see, you need to use 3 and 4 and 1 and 1. We put it into formula, which is 3 multiplied by 4 minus 1 multiplied by 1. We will get 12 minus 1 and we get the answer minus 1, which is 11. After that, we can calculate the cofactor 11, which is the formula is negative 1 power of 1 plus 1, which is the row and the column, then we multiply by the minor of the 1, 1. So we can get the 11. So let's move to M12, which is the first row and the second column. So the rest of numbers that we still have is 1, 1 and 1, 4. So after that, we still use the butterfly method, which is 1 multiplied by 4 minus 1 multiplied by 1. And we can see here, we can get the 3. So to find the cofactor of 1, 2, we can use negative 1 power of 3 multiplied by 3. Let's move to M13. So for M13, we still use the same method for the others and for the rest. So we make it faster, so we can get 1, 3 and 1, 1. Still using the butterfly method, and we can get the negative 2. So the cofactor also same, but the differences is the power. So let's move to the second row, which is M21 until M23. So for M21, we deselect the second row and the first column. So the rest of the numbers is 1, 1 and 1, 4. We're still using the same method to minus the number in the rest of number, so we can get 3. So you can use the minus into the formula to find out the cofactor. So the power of the cofactor is 3 because 2 plus 1. And we can get the negative 3. After that, we find out the M22 using the same method as before and F the others. So we can get the rest of number is 2, 1 and 1, 4. Same goes as before. We need to minus using the butterfly method, and we can get 7. After that, we replace the 7 into the cofactor formula, which is negative 1 power of 4 multiplied by 7. You can get 7. After that, the last one of the second row is M23, which is after you deselect the second row and the third column, you can get 2, 1 and 1, 1. After that, using the butterfly method 2, and you can get 1. After that, replace the 1 into the cofactor formula, which is negative 1 power of 5, which is 2 plus 3. After that, multiply by 1, and you can get negative 1. So that's how you solve the second row. Let's move to the third row. For the third row, which is the last row, you need to deselect same as the before. So for the M31 until M33, you need to deselect third row, which is the last row, with the different column, first until 3. So the M31 is first column and the third row. So the rest number that leave is 1, 3 and 1, 1. Using the butterfly method too, so you can multiply the 1 multiplied by 1 minus 3 multiplied by 1, and you can get negative 2. For negative 2, you replace in the cofactor formula, which is negative 1 power of 4 and multiply by negative 2, and you can get negative 2. Same goes to M32 and M33. So for M32, the rest of number that leave is 2, 1 and 1, 1. So from the 2, 1 and 1, 1, we can get the minor of the 3, 2, which is 1, using butterfly method as before. So the 1 that we get from the M32, you can replace it into the cofactor formula using the power negative 1 of power of 5. So negative 1 power of 5 multiplied by 1, we can get negative 1. So the last one minus that we need to calculate and cofactor that we need to calculate is MT3 and C33, which is MT3 is we deselect the third row and the third column, and the number of the rest and the number that the rest of the number that leave is 2, 1 and 1, 3. So from the 2, 1 and 1, 3, we use the butterfly method. So we can get 2 multiplied by 3 minus 1 multiplied by 1, and we can get 5. After that, we replace the 5 into the cofactor formula for C33. So for C33, we using the negative 1 of 3 plus 3, which is 6, and multiply by 5, and we can get 5.
In conclusion, cofactor expansion provides a simple and effective way to calculate the area of a triangle using the coordinates and its vertex. The method shows how linear algebra concepts like determinants can be applied in solving real-world geometry problems.